we're going to try to show what Taverna what the AstroTaverna plugin looks like. So we're going to start Taverna, and because we have already installed the AstroTaverna plugin as per the instructions which can be found in the Workflow Forever website, we have access to a range of blocks and also of design elements that we can use to create virtual observatory aware workflows within Taverna. So after starting the application, we will see that we have new tools in the Astro tools. We have these Astro tools here, and from the Astro tools we have columns for tools for adding columns using an expression, so that we can have calculated columns. We have coordinate columns. We can do coordinate transformation between, say, galactic coordinates and equatorial coordinates. Format conversions between, for instance, files which might be in CSV format and VO tables for the rest of the operations. Coordinate resolutions, column selection, row selection, and table joins. So these are possible through tools which are based on the Steel library. And we also have VO services where we can query the registry, and by using keywords we can add cone searches, we can add simple image access searches, or simple spectral access searches. We're going to try and use the VO registry to find data from the Sloan catalog. So we're going to do that by looking for the SDSS data release 8, typing those keywords here and clicking on the cone search button. We will be querying this registry endpoint here, which corresponds to the EuroVO registry, and we querying it on the SDSS tier 8, and we returning this. So we had the version that is being held at CDS, we had the version that is being held by the University of Edinburgh, and we can see the different metadata for the services here. So this is the catalog, the registry metadata for this entry being entered. So we will be adding this element to the workflow. Typically the short name will be used for the block, because in this case this one has a blank short name. Then we will see that this is being added as a cone search service with no special short name. We're not going to type any array deck or search radius here, because if we do so, these will not be allowed to be input ports for this service. So we will just simply add it to the workflow. We have it here. We'll show the input ports, and we're going to do a search around SIG 194. This happens to have an array of 115.12.02 and a declination of plus 83.7910, and we're going to put a search radius of 0.02, so that this 0.5, so that this is not too long. This doesn't take too long to search. We're going to add this XML output as an output port, so cone search VO table. So we're going to run this workflow, and the service is being queried. the view table has been generated, and in this case we have an empty table data set, so we need to make the search parameter bigger. So let's change it here. We edit it. We're going to put 0.1 so that it is not too big. Let's see how it goes. It has taken a little bit longer, so we hope we have some text in here. Exactly, so we have some input. And so the good thing is that we've seen this as text, because the view table is XML. We can see it as an XML tree, but that's not too helpful. That's only helpful when you're trying to build some operations, but here we have no context. The fields are up there. So the best way of showing this data is by clicking in the pop-up menu and selecting the view table renderer. With the view table renderer, we have a table display. We have all of the fields. We can see that in this case we have a lot of fields here, and that possibly it might be that it's not what we want to have for our particular analysis. So if we were just interested in sort and some of the classifications and for instance object type, the class, subclass, and we could have the CX, CY, CZ, for instance, we can use for that the rest of the Astro services that we've done. So for instance, for selecting columns, we can do that by adding this box here. We will have the body come into the view table, and the filters can be very simple. So we can say we just want array and deck and class. So if we do that, we're going to add this as a new output port, and this is the, yeah, we're going to use to go with that normal one. So if we run the workflow now, we're doing the same query again, going against the server. It's going to return the view table. Now the columns have been selected, and in this case we can see that the value is much smaller. You can see it in the text, and of course we can use the view table renderer, and here we just having the array, deck and class columns for this type. So we now going to use the SIA search services. So we're also going to go with the Sloan, and in this case the latest release is just being held by NASA. We can see also that we have less services than we have for consearches, because these are a little bit more complex. You need to be able to serve more metadata for the images that you need to serve for the consearches. So even when the search is taking more or less the same, just by typing SDSS, we just have several services. So we're going to go with this one, and we're going to add it to the workflow. So we can see here that we have a series of parameters. Position and size are the two which are mandatory. That's why they are being put in there. And then there are some others which are optionals, which can be added. One of them, for instance, which is of interest, is n-axis, which will give the size of the cutout. So we're going to add that one, and perhaps the equinox and the projection types such as tan. So we're going to add this to the workflow, And again, we will be showing the ports for this. We're going to set the equinox to FK5. We're going to set an axis to 1024. We're going to put the position in this case for SIG 229, which happens to be 121.557, comma plus 11.793, and we're going to say that the projection type we want to have is the tangential one, so for that we type tan, and for the size value, this is for searching, so we're going to go with 1 degree. Again, in this case, we're going to have the response body as a new output port, and let's run this. So this should be running. There is a slight delay, which I'm not sure if it's due to the load in my machine, which in principle is not doing much. Okay, I have an alert. Okay, there. So all values, the service is being called. And finally we got our answer. And our answer has a number of fields. We can show them again in the view table view so that we can see that we have in these cutouts. And in the case of the service, we have in both feeds and JPEG format images being served. We have in the URL for the cutout, and we have in logical names because these are like different plates. This is that we have in ones from the G band, I band, U band, R band, and Z band. So this is quite interesting, because this allows us to use some other tool that we have. We show the select columns tools, but in this case we want to have the select rows tool. The results of this workflow were duplicated between JPEG and FITS files, and if we wanted to select only those rows that corresponds to FITS files, we could have done differently by specifying the format parameter here, but we can also use our Astro tools here to select rows. And in this case, so we will select rows from this view table, so we pass it to the view table port. We set the filter. We need to use the still syntax to do that, so we have to do the equals format, being that the name of the column, and we want to be that image fits. And so we want to have this as a new output port, and if we run this, we can see that indeed we can see here how the table has 10 rows, whereas for this one the table just contains 5 rows, and all of them with format image fits. So that's how you select particular rows from a view table. So we might also try to get just the URLs for downloading. So we can do that. We can just go here again, use our select column box, feed the output table to the view table port, have this value here, just saying that we're just interested in the URL field, and we're going to have this as again an output port. We do our running, we wait for the workflow to execute, and here we have that we just have our table with the URLs for actual download of the image data from these services. A tool that is very useful in astronomy is the ability of being able to resolve the coordinates. We have services that can give you the coordinates for a given object, given its name, and as we've seen in the previous examples, we already had to provide array and DEC for all of the services, but many times what we have is a source name. So how can you query on coordinates when what you have is the source name? That's what we can do with the tools that we have for coordinates resolving. So we can add the resolve coordinates box. We show the ports here. We can see that we have to provide a view table which contains the columns. We have to provide the column that has the object name. We have then to provide the column name that the declination column will have and the array column will have. And all of these are mandatory. So in order to do that, we could try to provide just a text file. But if that were the case, so if we try to do something like this and say that we have here, we want to have SIG 2 to 9, for instance, we want to have that, and we want to have the we're going to call DEC 2000 to the declination column, and we want to call array 2000 to the right ascension column, and we're just going to say that we want column 1. We could try to see if this could provide some coordinates. We test it, and we will see this will be faster because this is a local service. We should get an error for the coordinate resolution. Why? Because the input parameters are not valid. So we actually need to provide a view table to this service. But we can convert tables with the format conversion element. So what we have to do here is to delete this connection and actually provide this as the view table. We have to say that this view table is going to be an ASCII table, and that we are going to provide a view table and so this one is going to be the input to the resolve coordinates service. So we test this, and the resolve coordinates in this case provides a table where we have this SIG 2 to 9. So we have a problem here. Problem is that we have two objects, and that's not what we want. So we have to do another tweak here, which is saying that this goes between quotes so that this does not get separated automatically into two different columns. We run this, and in this case, let's use view table render. We see that we have a sig 2 to 9, and then two columns, array 2000 and declination 2000, which are the array and dec that we want for this object.